Hello again, everybody. Today we're going to do something slightly different. We're still on Open Code and still creating our Game Boy CPU, except this time I decided to upgrade the size of the model a little bit just to see how well everything is with that. So I've upgraded to Devstral 2. Let me just show you. Devstral 2 123B Instruct. Before I was using the 24B version, and it was doing great. Except one thing that I noticed was that if you ask too much from it, it sort of has a hard time. So I'm wondering if we upgraded to the bigger 123 billion parameter model, if it can actually do more at once. And this is actually a dense model, so it's not MOE, so it is going to inference slower than what we're used to with models of this size. I think the closest one you could probably think of is GPT OSS 120B, but GPT OSS 120B is an MOE model where there's only a few billion active parameters per forward pass, when it generates one single token. But this one is 123 billion all at once. Obviously, my desktop can't support that, which, by the way, I have upgraded. I got a sweet deal to bundle CPU and was it CPU and motherboard. So I got a 9800 X3D now as a desktop, and because of that, this Windows desktop is a little wonky. I've swapped from Intel to AMD, or yeah, back and forth. And I think I'm just gonna wipe this and just put CachyOS or something on it now. I'm tired of the Windows thing. I just usually run it for experimentation, but I don't have anything active that I want to do. Anyway, back to here. It's not going to fit in our system, not going to fit in our 5090, but I do have my when the time comes, my RTX, my dual RTX 6000 ADAS GPU server. So I've loaded up the model with 64K context in with Llama CPP, split across these two GPUs here with 48 gigs each. So I can fit a Q4 quant of 123 billion parameter model with 64K context length. Yeah, into that, I've tried to use it. I've implemented a CCF instruction with it. It took about 9 minutes. And so it's not too bad. And it got everything in one shot. It seemed it didn't struggle at all. So that's a good thing. And so now I just want to just go through and implement more on camera now that I can trust it. So far, it does feel more accurate than the Devstral Small. So that's great. And I feel like maybe this could, I mean, from the benchmarks here, it's comparable to the full, even better than the full GLM 4.6, Quint 3 Coder Plus, and then also it's like punching at the level of GPT 5.1 codecs, and perhaps even like spitting distance between like these other three, especially Claude Sonnet, right? Okay, let's get on to it. So my prompt is just what's the next easiest opcode to implement now? Because I've already implemented SCF, and see the token generation is not too bad, and I've already used up 45K tokens. I found that OpenCode is pretty good at summarizing the context anyway. So I'm not too worried about this nowadays. I just want a reasonable amount to at least hold the prompt and maybe like one turn of something. Okay, so the device here is either CPL or DAA. Okay, so between these, CPL is definitely the easiest. Okay, since it's a simple bitwise operation that complements, meaning inverts all bits in the A register. So it's checking. Okay, so it hasn't been implemented yet. So what does this instruction do? It performs a bitwise not on the A register. That's all it really is. Sets the N and H flags. I think negative, and I forgot what this was again, but whatever. Takes 4 cycles, has no operands. Okay, so what's it doing? Okay, so now it's just gonna go on ahead and update the code to implement CPL. Now I should probably have it like not do that right away. Instead, always confirm with me before it needs to do something. So I'm going to tell it to do that once it has implemented the CPL instruction. I'm not mad about it because it is like a simpler opcode to implement. But as we get more complex, we don't want the agent or the AI running out of control. Okay, so it's pretty good at just even reading the code, and the token generation is not too bad. If we look at here, it is, where is it? So yeah, prompt eval is about this one is about 93 tokens per second, but then generation is about 9 tokens per second. That seems like just enough for us to tolerate as I'm speaking. Yeah, so I think now it's just going to add to dispatch table and then add tests for this and should be good. So right after this, after we the open code has shown us all the tests have passed, I'm going to say, hey, can you not act on your own like that? Always ask for my confirmation before performing edits and all that, just to make sure that we're aligned with some of the implementation rules. Okay, I'm going to let this finish up and then we'll resume the recording. So now it's just implementing the tests and it has hit a snag, um, basically some syntax issues. So it's going to, it found out what it's doing wrong too. So it's just going to go and correct itself. Um, I've seen this before already, so I found that it usually, at least the model will usually find a way to get it done. So I have the arguments in the wrong order. The get register method takes the register name first and then returns a value. I need to fix the assert equal call. Okay. Well, that's strange. Devstral actually finished writing the tests, but I'm getting an error saying that the request with 66k tokens exceeds available context size. Try increasing it, which is really strange because I've never hit this issue before. um, and and on top of that, like I expected it to compact by itself, the open code, and I'm seeing that I had to manually do slash compact. And on the Llama CPP side, got a lot of errors because of the lack of context. So that's really strange, and it's kind of it's trying to retry. I have no clue what's wrong. Um, okay. So I'm getting this weird retry error, Jinja exception. After the optional system message, conversation roles must alternate user and assistant roles except for tool calls and results. Okay, that's a weird restriction. So maybe we're in a bad state. Let's do this. Mm, let's do escape to interrupt. Okay, so let's compact again. Nope, that doesn't work. So how are we gonna do this? Let's just update. Maybe, okay, so this is not gonna work. So what we're going to probably do is we are going to maybe start a new session and then tell it to finish off. So let's try that. Okay, new session. Finish off what you started. I think you just wrote CPL tests at agents.md. Make sure all tests are passing and update your progress in agents.md. So let's see. Uh, let's see if it can pick up where it left off. If that's because there's something wrong because this used to work before where it would like auto compact. Yeah, a lot of people actually don't like this. Since I don't have many resources, I mean, 64K is a lot of context, but not for like coding. I would prefer to just compact and just give it context anyway, but that's okay. It looks like it was able to kind of pick up where it left off anyway, so it's a good sign. Okay, that's working out nicely. It was able to update the agent .md for the remaining opcodes necessary, and the number of tests it had added. So now we have 258 tests total. I don't know what else it's doing. It seems like it's still working, so I'll just let it be. But that took, I would say, like 5 minutes. I'm wondering if that's actually worth the pace that we're going. But, to be honest with you, if we can build some confidence with this, we can just like have it implement like five more and just like walk away and hopefully it can figure something out and then come back. So before we do that, once this is done, I'm gonna commit and I'm gonna try that. And I'm gonna also try to like say, well, actually, no, let's actually have it implement interrupts, and then let's discuss that like part before it actually tries to implement it. So I discovered that Mistral has their own coding agent called Mistral Vibe, and I want to try it out. I think it might be tuned better for Devstral. Who knows? But I've also set it to auto compact once I hit about 48K tokens. So let's see if that actually works. So let's try to implement yet another opcode or instruction and see how that goes. My face isn't blocking important information. Okay, so my prompt is read at agents MD and emulator design.md to get up to speed. Important, my preferences is always to have you confirm with me what you will be doing as opposed to being fully autonomous and making edits without my approval. I prefer discussions first because I want to learn. It's true. So let's see how fast it goes. Um, Server right now is already processing. I guess in this case, there's about, oh, it's pretty fast, about 15,000 tokens, and it's already doing stuff, I think. Or is this from another? Yeah, so about 16K tokens. I don't know. Oh yeah, it is. Okay, so he or she has read through the agents in Design MD, summarizing. Okay, so it's got it right. Game Boy emulator REST API interface, focus on CPU graphics, sound, and input emulation. Play Pokemon Red Blue using AI controlled inputs. About 207 opcodes implemented out of 512 total, 258 tests passing. Uses dispatch table pattern for opcode handling. Operand values prefetched into CPU to operand values list. Great. Okay, critical implementation rules. Operand fetching uses if bytes and operand to distinguish memory fetches and register operations. Condition code handling must check is conditional before skipping Z and Z, C and C. Okay, handler signature. Okay, cycle accuracy must match opcodes.json specifications. Common gotchas. Okay, missing opcodes, key ones. Okay, so we're missing all of this. Your preference, discussions first, want to learn rather than autonomous edits. Okay, so yeah, what area would we like to explore? So it was indeed about 16, no, about 17,000 tokens. That is about 35% of our usage. But yeah, let's do this. It seems like the remaining opcodes may rely on interrupt processing. Perhaps we should discuss how on the design of that and how to implement it. I am not familiar with GB interrupt handling, so maybe it would be good for you to teach me and we can discuss and establish an overall implementation plan. Yeah. Okay, cool. It's teaching me now. So let me teach you about the Game Boy interrupt handling and how we can establish an implementation plan. Okay, let me first check what's currently implemented in the interrupt system. All right, so 890 lines from gbcpu.py. I wonder if I could hook up the Kagi MCP for this so that it can search when it needs to. Um, MCP? Is it MCP? Model, proxy. I guess not. I guess. Let's see here. Oops. Oops. Continue. It was an accident to interrupt. uh, okay. Oh, I guess it had enough already. Okay. So the Game Boy has 5 interrupt sources, each with a fixed address. So you have V blank at memory address 0x40. You have LCD controller status changes. Okay. Uh, LCD controller status. What is that? Is that like, I don't know what that is. Timer overflow, serial transfer completion. So link cable, joypad button press. Okay, so that maps to like the current key. So the interrupt system uses several memory map registers, i.e. interrupt enable, 0xFFFF, enables, disables each interrupt source, interrupt flag, and then also interrupt master enable. So that's a CPU flag, okay? Interrupt processing flow, hardware sets corresponding bit in IF, CPU checks if IME equals 1. Okay, so IME is the interrupt master enable flag. Okay, so if both are true, the interrupt will be handled. IME is automatically disabled. Okay, so you can't do any other interrupts while you're handling. The current PC is pushed to the stack. PC jumps to interrupt handler address. I'm guessing right here. Okay. And then interrupt service routine executes. So basically the code that's in these addresses. Return from interrupt instructions returns and re-enables IME. And then what else we have? So looking at the code, I see interrupts class exists but is minimal, only has enable flag. Return from interrupt instruction is implemented but likely doesn't fully handle interrupt state. No interrupt checking in the main CPU loop. No memory map register handling for IEIF. So I'm missing opcodes. Okay, so here's what I need to implement. Phase 1. Okay, phase 1. Core interrupt infrastructure. Expand interrupts class with proper state. Add IEIF register handling in memory. Sure. Implement interrupt checking in CPU loop. Add DIEI handlers. Okay. Interrupt service routine. So these are the. Why does this keep coming up? It's weird. Okay, so this one is going to be the functions that we'll run, and then we'll implement these opcodes. So the proposed implementation will be the interrupts class, which we already have. We are going to have some instance variables that determine whether or not to do interrupts. We'll check for pending interrupts and service them and enable. Okay, so no cycles. If the interrupt's disabled, we don't do anything. Otherwise, we are going to service interrupt. Service interrupt is just going to be the handler address. Okay, so handler address. So for example, 0x58. We'll push the current word. Okay, then we'll set the PC to the handler address. And then I think we'll just run it, right? So we'll clear the interrupt flag. We'll clear the interrupt flag. Is that part of the flow? So, current PC pushes stack. Clear the interrupt flag. Oh, indicates when interrupts are pending. It's no longer pending, so we're handling it now. And then we're gonna set value to clear the specific bit that triggered this interrupt. So this is interrupt. Okay, so this is the flag right now. We're going to just toggle it, set it, and then interrupt handling takes 20 cycles. Okay, cool. So phase 1 is that, where we implement the handlers and the interrupt class, and then phase 2 enhance, okay, add memory mapped address. Okay, let's just start with phase 1. Okay, phase 1 seems good. Let's just do that first. Okay, so let's just implement phase 1 of the interrupt system. expand the interrupts class and adding the necessary handlers. So yeah, we'll just let it do that. It's probably going to take a bit, given that it's a 123 billion parameter model. It seems like our GPUs are taking it really well. This is actually pretty tight right here. 47.8 out of 47.9 gigabytes used. And then yeah, this one's also pretty tight too. So we have a memory spike, we're screwed. About 450 watts being drawn from the wall for these two GPUs, which is not bad. So yeah, okay. So it's gonna just generate now. We'll just come back soon. The thing is that now, Vibe, Mr. Vibe, has asked me if I want it to make these edits. I'm just gonna say always allow search replace for this session because I want it to be like when I say yes, do those changes. I want it to actually do those changes without like kind of stopping every little thing. I just wanted to stop before it actually does something without me knowing. That's the problem I have. But it looks like it's implemented a few things here, so I'll just let it go. Whoa, it's like quite a bit. Um, yes, it's I think it's exactly what it had mentioned before. So looks like it's going to now go and add, yeah, the interrupt stuff into the main CPU run loop. So after every single cycle or instruction that is handled by the CPU, it's probably going to check for interrupts to be serviced, and then most likely call into this class to actually do that. So that I don't know how long it's going to take, but it doesn't look too bad at all. In fact, I feel like this is faster than open code. Okay, so and now it's going to implement DI and EI handlers, and then so it's going to create a file from scratch, taking a look at the work being done by the GPUs. About half, both of them are at half utilization. About 80, 87C. It's hot for my tastes, but these are workstation blower style cards, so I think they're meant to like take that much abuse. Okay. Uh, yeah. Just keep letting it do its thing, and maybe just check back later again. I'm okay with the speed because it's not frustrating me right now. It seems to know what to do, and it hasn't really like gotten lost yet. Okay, so now it wants permissions to do a write file because it's creating a new file. So I'll say, okay, yeah, let's always allow that. And now it is going to probably yeah, just modify the GPCPU file to just import the handlers, and then it's going to modify that dispatch table to add pointers to those handler methods into those opcodes. So it has implemented DI, EI, and halt. In this case, I think it's already, yeah, it's already been collapsed, but it's there, I think. If we go back here, we can look at the interrupt handlers. We'll see halt here too. Cool. Yeah. Okay, so now let's enhance the return from interrupt handler to properly re-enable interrupts. So the current implementation has been checked. So now it's implementing that. So far a total about 5 minutes to do all this stuff. Context windows healthy, 62% of the 48K token, so it hasn't had a need to um, compact yet, but I'll have it compact at 48K just for safety, even though it's like a 64K context window. Okay, so interrupts IME, so I think that's the new way to do it in here. Okay, so basic test to verify our interrupt implementation works. Okay, so it's created some tests. What does it want me to do? it wants to run. Okay, so let's always allow bash. Failures, so it's written bad tests, but I think they're all just interrupt tests. Okay, so the tests are failing because the run method doesn't return the number of cycles used. Let me check how the existing tests work and fix our test approach. That's fine. I mean, because it doesn't really know our repo yet. So I see the run method doesn't return cycles, it just updates the current cycles. So now it's going to fix the tests. So I think it's pretty robust. It's good piece of software so far. I wonder now. It's like if we go back to Devstral 2 small, um, how is that going to be like? Is Vibe going to work really well with it and take advantage of the model smarts now? Interesting. But I'm definitely liking the experience here. It's even though it's a little slower, and it's Q4 Quant too. So far, so good. And it taught me a little bit about how the interrupts work. So yeah, let's just oh, it's already okay, whatever. um let's see. So I think this is probably all it needs to do, most likely. And then wonder like is this a Mistral thing? Maybe so, because when I do the selection, it's I get to actually skip these things here. So it is most likely that, yeah, it makes it very convenient to like copy and paste. Actually, I'm starting to like this. It's just that it feels just a little slow, but I think it's just because of my like somewhat, I think at this point, broken Windows install. I mean, if you take a look at this, I have no clue what's going on, but my CPU is always like not, it's like boosted all the time, and there's always some sort of weird CPU activity. Nothing's really changed, so I'm not sure what's going on. But I think I'm just going to eventually wipe this computer and start from scratch properly. I really only needed this Windows for DaVinci Resolve to edit these videos, but I figured out recently how to actually properly install DaVinci Resolve on Linux. So maybe I'll just go back and just be on Linux again. Okay, so it finished altering the tests, and to a point where now 6 out of the 7 pass. This is funny, sending good vibes. So basically, the halt instruction, the halt test is not correct. The PC is 0x41 instead of 0x40. This is because after the halt instruction executes, PC increments by 1, and then the interrupt service pushes that address to stack. So let me fix this test. Okay, sending good vibes. Okay, so the agent ended up compacting the conversation history, and um now I think it tried to run the tests again after doing stuff, and I think it's getting failures for still the same thing. It's hard to tell because the output has been truncated. um yeah, let's see. So it should probably do a tail, to be honest. Yeah, tail. So set locale LCR cannot change locale. There's one failing test in the existing suite. Test run RETI is failing because it's checking for CPU interrupts enabled, but we changed the API to use CPU interrupts to IME instead. Let me check and fix this test. I need to update this test and use the new IME flag instead of enabled. Let me fix this. Okay, so this is where I start to feel like it is getting a little slow. Um, and so I don't, again, for quick vibe coding, probably not the best thing unless you have a lot of time. But I do trust it to do a lot more at once. So we've barely finished phase 1. That took about 27 minutes. All right. Not sure whether or not that's long or short, given that I think for myself, I would have taken probably about 15 minutes for all of this, if I understood the requirements very well. So maybe it's about human pace. Maybe it's like working with someone, you're just like telling them what to do. Um, except that they write tests a lot faster, probably. Okay. Yeah. So now let's do phase 2. And then yeah, I think that'll be pretty much all for today, most likely. Let's just going. Okay. So yeah, let's do phase 2. And then okay, so I've changed the context window compaction limit to 56K tokens. Hopefully that kind of makes things go faster since it doesn't have to auto compact as often. So yeah, let's just start a new session and let's finish phase 3 of the interrupt handling process. Let's finish phase 3 of the interrupt handling process, see agents.md. And you can refresh yourself with that design.md. Okay, so let's just get things warmed up here, and then we're going to do the rest of the phases for interrupt handling today. So here it looks like we had to give some permissions because it's a new session. So I'll say yes, you can run bash for this these sets of unit tests for the rest of the session. I think what it's doing is a really good thing where it is trying to understand the code and also just running the tests just to get a good baseline on what's going on. Uh, yeah, so right now the generation speed is not too bad. It just gets slower as the session just goes on. So yeah, this is basically phase 3 again. It's about the timing behavior. Um, yeah, so it's just implementing now. I think I should have reminded it to always ask for like my confirmation before doing something. But let's see if it can actually handle it. Maybe at this point the requirements are clear enough where it doesn't really need that much handholding. So yeah, let's always ask, or let's always allow the search and replace IME pending. So it's adding a new flag to delay the EI instruction. So at some point, maybe after like one cycle, that's gonna turn to true if there is something. Most likely, it's gonna do something with like a delay with like a single cycle. Okay, so yeah, so now there's something with setting it to be true. Okay, so we'll handle delay in the future refinement. Not exactly now. We have to do that here because that's the whole point of phase 3, right? So update the CPU run loop to handle the delayed IME enable. The logic should be after executing an instruction, check if IME pending is true. If so, set IME equals true and clear IME pending. Okay, so now it's handling the IME enable from the EI instruction. So if it's pending, so just set to handle, then also set IME pending to false. That's okay. I'm wondering where the delay is coming from though. So EI doesn't enable interrupts immediately. Interrupts are so EI just sets it to pending. That's right. That's right. So EI sets it to pending, and then after that one cycle, basically after the current instruction is finished, then it'll basically run this here. Okay, so let's check something out real quick. Um, let's see how EI is actually being handled just for my refreshing. EI, right here. Okay, so what EI is doing is it sets the interrupt master enable IME flag to 1, enabling interrupts, but then they're not enabled immediately. They become enabled after the instruction following EI is executed, which is basically this one right here, right? So if you're setting it to pending, right? IME pending, then in the next cycle or the next instruction, this if check happens, and then that's when we actually set the interrupts enable to be handled to true. Then we also turn off the pending flag so that we're not in this perpetual cycle for checking if there are interrupts to be handled. Okay, that's actually simpler than I thought. It seems scarier. One thing I'm thinking about is like after we finished all the non-CB opcodes, we're going to let's have like Claude just kind of like check everything again, and then if all things are good, I'm thinking about taking the risk and just maybe having this run in the background, implementing all the CB opcodes. Um, First, we'll probably have to refresh ourselves what CB is. So I think we had noted that in I think it was in design.md. So if we take a look at here, CB prefixed. Okay, so CB uh prefix CB. Just see. How about CB? Okay, we didn't really note that down, so that needs to be addressed. Yeah, so let's have it also explain what CB prefixed instructions are and have it update the design.md. Okay, that's fine. But we'll let this run in the background. It's just basically tests. So that's going to take a while. And usually, I do think that Devstral does struggle in creating tests sometimes because I think the test file is rather large, so it kind of gets lost in there. Um, but I think this one is relative. I get that. It's getting big, but I don't think we have much left to do, so we'll just leave it be. But yeah, it seems to always have trouble with the tests. Okay, phase three was done. My OBS crashed, but I feel like things were moving a little too slow, and so I decided to just sign up for Mistral AI. With It's free. I'm using the free plan, and it has access to the same Devstral 2 model. So I'm using that to just like accelerate this process. Um, Technically, I'm still using open weights model. So I'm not breaking any rules. And let's see how good this model is for bigger things because now we can move faster. And since it's 123 billion parameters, dense model, it should be pretty good without the limits of our hardware. So I've told it to just look for the code base to start on phase four, and I'm going to allow Bash again for this session, and let's see what it can do. I might have to tweak the auto compaction limit, but that's okay. Um, yeah, so let's see. Looking at the current test, I can see we have good basic coverage, but several key edge cases mentioned are missing in phase four. All right, so it's going to just add the test, and already it's just a way better experience because it's faster. What I'm probably going to do is also like configure the the window. Yeah, I'm going to do that right now. So basically it's going to be in the config. Uh, yeah, allow search and replace. So I'm going to up that to 200K so that it can maintain itself. I think that's what Devstral 2 is trained for. And notice like now I'm more forgiving for it to like mess up because it's so much faster. So yeah, well, let's always allow write file. Okay. What is it fixing? Okay, it's just indentation looks like. Okay. Is it actually writing tests? Ah, this has been so frustrating. So I've been recording on and off because just I think Mistral got itself into a really bad situation like over and over again. And so I'm just going to be using Claude now to just at least clean up the code and maybe just get more stuff done in this platform because I kind of want to actually have a working emulator and I think it's just too slow doing local models at this point. Yeah, it's been very frustrating. When I was using the local version of in my own server, it was doing pretty good, but it was just really slow, right? And then Devstral Small, I have a feeling can't really handle this interrupt thing, and so I have to resort to using Claude. And I gave it the situation where it's like everything's all where everything's all messed up, and we're going to have to like kind of get back to a good state. So Claude ended up scanning like the code base, and uh, it is going to lay down a plan in front of me right now. I haven't read it yet, but let's see what it consists of. And I think we can take more time to just like kind of read and think things through because now um, we're not really waiting too much on anything, given that we're just purely using Claude Code. So, okay, all right, here's what I found. Let me give you the full picture. The current state tests all passing, 17 passed, one skipped. The logic is actually correct. The mess is more about code quality than broken functionality. That's great. The problems I see debug print statements littered everywhere. 3 in GB CPU.py's run loop, and 5 in interrupt handlers. These fire on every single CPU cycle, which make the emulator extremely noisy and slow. 11 throwaway debug test scripts in which the project root left over from Mistral's troubleshooting sessions. Duplicated interrupt dispatch logic in halt. The halt handler has the same 5 interrupt priority check copy pasted twice. See, this is what Mistral was doing, or Devstral. This should use check interrupts instead. IME handled by instruction flag, an awkward workaround to prevent double enabling IME works, but is a code smell. Agents.md lists EI as both implemented and not yet implemented, contradictory entries. Proposed plan. I'd like to tackle this in order. Delete the 11 debug test scripts from the project root. Remove all debug statements from gbcpu.py and interrupt handlers.py. Refactor the halt handler to eliminate duplicated interrupt dispatch code. Clean up agents.md. Fix the contradictory entries in the not implemented section. Run all tests to confirm nothing broke. Want me to proceed with this plan, or do you want to discuss any of these points first? Damn. No, just go. Yes, go. It knows. All right. So it's just going to delete the debug scripts, okay? Let's see. And it's going to okay, remove, clean up. Is it already done? Let's see. Just refresh. No. So it's just I guess it's just figuring things out. All right, we don't need this anymore. So, oh, okay, it has these permissions. Yes, always allow. Okay, yeah, always allow. Let's see. So it did that already. It deleted. So already we should see that cleaned up. Okay. Delete or removed all the print statements, which is okay. I think it's just trying to clean it to get itself back to like a good state, and then it's probably gonna try and go from there. But yeah. Oh man. Okay. Well, I tell you this is what I've learned so far. If you want to get like be productive with vibe coding on local, using like a local instance, it has to be like very small type of vibe coding, and also like if you like given the hardware like you may have, I think using like a small model to just get fast iterations is actually better than a big smart model, except that if you run into situations where your small model is just not going to be able to figure it out, you're kind of out of luck. I just don't think we're there yet locally for bigger complex projects. But for sure, like things like Claude Code, it looks like this is like nothing for it. This is like kind of easy peasy. So that's just like the the demonstration of scale, right? It makes sense given that this is probably trillions and trillions of parameters versus something like Devstral 2, where it was 123 billion. So that's why I'm not blaming Devstral 2 too much. It's just that this is the difference right here, like in action of scale. So yeah, I'm going to, yeah, so let's just do this. Let's just stick with this and see how far we can get. Maybe we can even finish like a lot of this interrupt handling in this session here. So cool. So everything looks good and nice and restored. Let's see here. Um, yeah, look, the code changes were actually smaller than um what it seemed like Devstral was trying to do. So this is fine. These are just tests. Okay. Yeah, okay. Okay, now let's commit this cleanup. And then I guess to say, well, let's also I forgot, did it update agents on MD? It probably did, right? Yeah. Well, let's just have it. Okay. Um, can you push it? Push it. Let's push it, and then let's just have it update agents on MD and then see like if it can go with phase 5, 6, and 7, and so on. Okay, let's start. Let's update agents.md, and then let's have you implement the rest of the interrupt handling work. So we'll just have it do that, and then see where we can go from there. I think from here, I think implementing instructions would be pretty easy. So yeah, we just let it go. It shouldn't take too long, given that I was able to fix all that rather quickly. It's funny though because I think Devstral actually implemented the right logic from what Claude said, so that's a good thing. It's just that it had problems. It probably just got confused with all those print statements and whatnot. Which I feel like Devstral should have kind of figured that that was going to be a problematic move. Yeah. I'm also thinking about like taking a break from this fight coding stuff and just like program for real again on video. But I don't know how useful that is for anybody. So maybe it isn't even useful either for most people. You're just watching a guy type in a CLI. But if you like it, you like it. If you don't like it, then don't watch it. Okay, so Claude has written up a plan, and let's see what it is going to plan on doing. Haha, plan. All right. Plan complete interrupt system implementation. The interrupt system has an EI delay, DI halt, and RETI return from interrupt working for the happy path, but 3 bugs and missing edge cases coverage block phase for completion. 1. Run loop ignores the halted flag. CPU keeps executing instructions after halt with no pending interrupt. DI doesn't cancel a pending EI. EI DI NOP, or just a no op, incorrectly re-enables interrupts. Halt bug is not implemented, or halt bug not implemented. Real hardware quirk when halt runs with IME equals 0 and pending interrupt. So real Game Boy has this really weird halt bug. All changes below are atomic. They must land together since they affect the same code paths. All changes below are atomic. Okay. So meaning that they have to all be implemented at once. So changes. Fix DI handler is a one-liner. Add this false to DI so it cancels any pending EI. Okay. Add halt bug flag to interrupts class. So we had to purposely add a halt bug. One shot flag tells the run loop to not advance the PC after the next fetch. Okay. Refactor halt handler to cover all these cases. Sure. Uh, and then remove self.halted guard from the check interrupts. Add halted idle loop and run. So that's just going to do nothing, I think. Let's see. If halted, then just get the registers. If both are already set, then halted equals false. Otherwise, we're just going to like consume cycles. Okay. Um, okay, new test methods, update. Okay, yes, go for it. Yes, clear context and auto accept edits. Yes, auto accept edits. I guess auto accept edits? How do I know how much context I have? So is there like a context thing? Visualize current context. No. Okay. Context. Whatever. Okay, so wow, it is flying. All right, 9K tokens. Um, I'm not sure if this costs a lot. But okay. But yeah, it is just churning out code. So yeah, it's pretty much rewriting some of the interrupt stuff. That's okay, as long as it works. Update agents and add edge case interrupt tests. So already it's adding tests. That's pretty cool. So yeah, I think there's this pattern where I think a lot of these LLMs do struggle writing tests. Uh, at least non-web development style, I guess. Yeah, this is like very familiar to me. This is like what happens with Devstral 2 all the time. So I think it's gonna be okay because Claude is a lot smarter, and I trust I can find its way out of it. Okay, analyzing the root cause. Sure. So it's found bugs based off of the tests. Okay, let me rewrite the failing tests. How long is that going to take? So it took, oh, it was a double no op. Interrupt fires before this. Oh, okay, so at this point, it should already, okay, so that's no longer needed. So, okay, current cycle reaches 16, wake plus 20. So some of the cycle counting was actually wrong. I wonder if we need to keep that in mind when, like, maybe when we're done implementing CPU, we need to figure out like how we're going to make sure that we're cycle accurate. Okay, so apparently we're done with phase 4 now. As of March 15th. Oh yeah, that's interesting. I think somebody hallucinated that. I think it's Devstral. So yeah, okay, great. Now phase 5. So but let's commit and push. Great. Run the test one more time. That's a good thing. Okay. I do want to see like what great, cool. How about let's commit and push this? I do want to see what our context is like after all that. Let's see here. So let's just give it some time to push. Now context. I want to see the visualizing context. Okay. So system prompt was 3.2k tokens. System tools. Okay. Skills 61 tokens. Messages. Okay. 89k tokens. We have free left. Okay. Auto compact. We have a 33k headroom. That's cool. Let's finish the rest of the phases with Claude. Okay, let's move on to phase 5. So now, at this point, we take a look at agents.md. Phase 5 would be advanced interrupt handling scenarios, so nested interrupts during halt. Okay, memory boundary edge cases, priority conflict resolution test. And I think these three can be left alone first. We're going to implement all the other instructions first. So I might have it like kind of just do a full sweep on the leftover instructions just because it's probably going to run into like instructions where it needs implementation. Expression show phase 5 is purely a testing phase. The architecture already handles all these scenarios correctly. Let me write the plan. Oh, that's okay. So let's read this. So okay. Context phase 4 fixed the last interrupt bugs. The architecture now correctly handles all advanced scenarios, nested interrupts, halt with different types, memory boundaries, and priority conflicts. Phase 5 is purely test coverage to validate these scenarios and prevent regressions. No code changes to gbcpu.py, interrupt handlers.py, or gbmemory.py are needed. Changes, nested interrupt tests. Okay, so we just need to have some tests. Halt with different interrupt types, memory boundary edge cases. Okay, priority conflict resolution, and then we'll just verify by running. So we expect around 9 new tests. All existing 282 tests are still passing. Okay, yeah, clear context and auto accept edits. Should we? No, let's just have it do that on its own. So Flibberty Flib what? Flibberty Gippeting? What does this mean? Anyway. Yeah, again, I don't expect it to take too long. So maybe if we take a look at phase 6, we can't really test with Game Boy ROMs yet. So let's pause on these and then let's have it implement the rest of all these opcodes here. So at this point, I think we're pretty much approaching over 100,000 tokens now, but I think that's okay because I think Claude can do like 1,000,000, no problem. Okay, phase 5 is done. All the tests have been written. I think it already committed and pushed. Yep, it did. Whew. All right. Okay. Let's do. Well, let's see. No. Let's hold off on phase 6 to 8 because we haven't implemented all the opcodes and video, sound, etc. yet. Okay. So I think the next step will probably be other stuff. Okay. Let's see. How many other opcodes that are not CB prefixed are left to be implemented? And then if it says like 10, it's like just do it all at once. Okay, it came up with all the other opcodes, so it's 22 missing. Okay. So that's okay. So here 14 on load stores. That's promising. 4 on conditional, arithmetic, special. So really, just do all of them. Okay. I think all of them seem I don't want to say trivial because it does take thought. Seem trivial and can be done all at once. What do you think? Or maybe we do each category at a time. What's your thought? I'm gonna trust the LLM. Okay, I'd say do it by category, not because any single opcode is hard, but because, okay, easier for review, catch bugs incrementally. Sure, let's do it. Sure, just do it. Or actually, yeah, let's do it and keep things stable and stable and good. Go for it. Okay, so we're just gonna let it run, and then we're going to come back, I guess, and just check the disaster or masterpiece that has been created. Wow, that was not bad. That was like 6 minutes and 58 seconds to get done for that batch, and it just flew and committed. So um let's go. Yeah, next batch. Next batch. And then heads up, if you are passing tests, let's just keep moving on to the next batch. Okay, so this will allow more autonomy and flow, and it just allow me to go take a walk or something. So let's see if it actually follows those directions, and we'll check back. Wow, geez, what a beast. It finished all the rest of the opcodes and it already committed and pushed. So just for fun, I'm gonna say, can you run the CPU tests, actually all the tests to see if we're passing 100% again. So 328 tests now. So it should still be 328. Okay, great. One skipped. Okay, that's a CB prefix placeholder. Clean bill of health. All right. Okay. Now let's update agents.md and then tell me what CB prefix instructions are. Might be worth to throw that information into the design document and agents.md if you find appropriate. Okay, so let's do some like preparation, I guess, because this is going to be, I think, the last 256, no, last 256 opcodes. But yeah, it's going to be the last set, and I think we'll have at least somewhat a functioning CPU. So let's just have it do that. Okay, so it has come up with a response telling me what CB prefix instructions are. So CB prefix instructions are the Game Boy's second opcode table, 256 additional instructions accessed via 2-byte sequence, 0xCB, followed by a second byte. So we remember this. When the CPU sees 0xCB, it reads the next byte and dispatches from a separate table. This exists because the SM83 CPU ran out of room in its base 256 opcode table and needed full bit manipulation shift rotate support on all registers, not just A. The 256 opcodes break down into 11 operation types across 8 targets. Okay, that's easy. So this is like the same thing. It just simply ran out of room on the addressing on the CPU. So yeah, the table is extremely regular. Same pattern repeats for all 8 targets, so it can be implemented with around 11 helper functions plus a data-driven dispatch rather than 256 individual functions. I've added this to reference to both the agents in design and MD. Okay, yeah, commit and push it, and then let's see how we're going to do this. We can just, so there are 64 bit BITRES and set instructions. So now let's begin implementing the 0xCB opcodes. Should we just do them by groups? In this case, 11 total. So I think we can get this done all in one shot. Okay, so we could do 11 groups, but honestly, the table is so regular that a data-driven approach can knock out all 256 in one shot. Wow, confidence. Write 11 helper functions, RLC, RRC, RL, RR, SLA, SRA, swap, okay. Write target reader writer functions that handle all these uniformly, generate the dispatch table programmatically from the regular encoding pattern. Okay, this avoids writing 256 individual functions and keeps it dry. The helpers are each 5 to 10 lines. Tests would cover each operation. Okay, doing group by group, meaning 11 commits share the same scaffolding. Yeah. All 256. Oh, wait. Should we name the helper functions with like CB or something to distinguish from the normal ones? Because like it's confusing, right? Like I would start to think that those are part of like the others. So yeah, good call. The CB prefix rotates share names with the unprefixed ones, but behave differently. Yeah, I know. Naming them with the CB prefix helps keeps things unambiguous. Okay, and the file will be CB handlers applying the dispatch table CB code opcode handlers, clear separation everywhere. Want me to go ahead? Yeah, go for it. Implement. Okay, go for it. Uh, 1, implement all 256. 2, write tests. 3, ensure tests are passing after every group implemented. 4, update agents.md agents.md regularly. And 5, do it all autonomously. Okay, let's see if it can just like do 256 in one shot, and let's see how long it takes and how many tokens it's going to drain. Okay, wow. It implemented everything within 6 minutes. That's pretty impressive. It created this CB handlers file that pretty much can handle all 256. It was not kidding that um really, since it was like very like there was like a pattern to all these instructions that you only needed 11 handlers to do all that. Makes me question whether or not this was the right approach here, but whatever. Maybe one day we can refactor. So I think the next thing, it's already updated agents.md and has already pushed and commit. I think the next test, or not next test, but the next thing to do is probably verify if the CPU is actually cycle accurate. Um, oh yeah, we need to remove that skipped CB placeholder test. I forgot that we did that. Or at least not me, but Devstral. Um, what I wanted to verify is if this thing is cycle accurate, and then we could probably start writing some code that can load ROMs. So maybe that's for next time. But I think next time let's go right into Claude and just see how much we can get done. Yeah. Okay. Yeah, so is that it for the CPU? Anything else to implement? CPU only? Yeah, I think because I think we've implemented all the opcodes at this point. Yeah, so it's gonna audit, and then I think from here we just verify if it's cycle accurate, and we'll go on to seeing if we can load ROMs, and then I think video and joypad. Not too concerned with audio yet, though. Let's see. Oh no, the only gap is stop. Everything else is complete. Yeah. Let's see. On real hardware, stop halts the CPU and LCD until a button is pressed. For now, it can be a simple stub like no op, since it's rarely used and needs joypad input to resume. Okay. Yeah, add a stub handler and make a note of it in agents.md. Yeah, let's do that, and then let's verify cycle accuracy. So while we're doing that, we can just think of our message, maybe. Let's see. We'll just let it do its thing first. Okay. All 500 codes are now implemented, commit and push. Um, yeah. Any way to verify cycle accuracy? Um, oh wow, we're almost gonna auto compact. Good question. We could do an automated check right now. Execute every single opcode and compare the cycle counts against opcodes.json. No external ROMs needed. That's great. That's a great way to do it. Every opcode cycle counts matches opcodes.json exactly. Let me also verify the control flow instructions, which I skipped above. Um, cool. I wonder if we can actually create an automated test script for that, just to test. Yeah, let's do that too. I think that's a valuable feature to have. Sorry, I'm just like stretching my back. Okay. So yeah, the only two not tested dynamically are halt and stop, but their handlers return whatever, so they're correct. Okay. Well, can you uh put what you just did into a test script that's comparing against the opcodes? That JSON seems to be very handy trick. Okay. So let's have that. So now we verified cycle accuracy to a certain extent. Now we need to have the ability to load ROMs. Again, I think that it just involves file reading. So you're just gonna open like a file, and I think we need to understand like at least a format, so we can actually start moving the program counter to the right place to begin execution. So um, yeah, I'm running out of time, so I might just resume this tomorrow. Maybe I'll just make a whole entire like this is like one video now. Like we're done with the CPU now. Okay, looks like it's done. So we're gonna commit and push it. It created the cycle accuracy testing script, and I think we're good with the CPU. So next time we're going to try and load ROMs, and yeah, thanks for going through the struggle with me. At least we're getting somewhere. Thank you.